What we have next is this little worksheet with some mixed nomenclature. A lot of it with nomenclature that we haven't practiced in a while, and this is just to help you review some of the different type of nomenclature. And what I would love for you to do is pause the video and see how many of these you can come up with on your own, and then unpause the video and see how you did. I just want to clarify that that's an iodine right there. And so when you come back, I'm going to be going through these names, and I'm going to go through them pretty fast because I feel like a lot of these, you know how to name these things. So pause the video, see what you can come up with, come back when you're done, and I'm going to start naming. So for the first one, remember that ethers, which this is not an IUPAC recognized functional group. If we wanted to name it common, we could definitely do a common name for this. That would work, but I would prefer to name it with a more IUPAC style name. In the IUPAC-ish name, we take the smaller R group and we name that as an alkoxy substituent on the actual alkane. So this would be isopropoxy cyclopentane. Don't let the isopropoxy thing kind of freak you out. Anytime we have an oxygen hanging off the end of an R group, we call it, whatever the R group is, oxy. You guys know ethoxy, you know methoxy. And so isopropyl just becomes isopropoxy cyclopentane. I'm going to go down this column. Looks like my longest carbon chain is going to be this one right here. I want to come up with the smallest possible set of numbers, which I think is going to be from top to bottom. 1, 2, 3, 4, 5, 6. If I number that way, my numbers are going to be 3, 3, 5, which adds up to 11. If I go the other way with it, 2, 4, if I go the other way with it, I'm going to get 2, 4, 4, ooh, 10. That's actually the better way. So I was wrong. Good thing I checked both ways. So there's the numbering system that we want to use for this one. Alphabetize our substituent. So iodine comes first. 2 iodo, 4, 4 dimethyl hexane. Same kind of idea down with the one underneath it. We're trying to come up with the smallest possible set of numbers for our substituent, which means if I've got a di substituent, I want that to be carbon number 1. 1, 2, 3, 4, like that. This is 2 bromo, 4 ethyl, 1, 1 dimethyl cyclohexane. One underneath it, this is an aldehyde, so that's going to be our carbon number 1, 2, 3. This is a 3 carbon propanal, but it has a double bond in it, so 2, no, I want to put the number in the middle, prop 2 enal. That's the cleanest way to do it. Down below we have a ketone. We want to give that carbonyl group the smallest possible number, which means we're going to be numbering from right to left. Putting our substituents into alphabetical order gives us 3 chloro, 5 methyl, 2 heptanone. And our next one, this is a benzene derivative. The benzene with the OH group on it is phenol. So this is a phenol with a nitro group on it. We can call it ortho nitrophenol, or we could call it 2-nitrophenol. Let's go up to the top. This is a really long carbon chain. I'm gonna try 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Looks like 7 is all I'm gonna get out of this. And I want the smallest possible numbers, which means I think I want to start numbering up at the top. 1, 2, 3, 4, 5, 6, 7. That puts my substituents on 2, 3, and 6, which adds up to 11. That looks pretty good. If I numbered the other way, let's just try it since I was wrong the first time. If I numbered the other way, 2, 5, and 6, that's definitely not right. That's going to be more than 11. So we're numbering 1, 2, 3, 4, 5, 6, 7. Our substituents are a methyl on 2, isopropyl on 3, methyl on 6. 3 isopropyl, 2, 6 dimethyl heptane. Next one, we have this cute little cyclic. The carbon that has 2 substituents should always be carbon number 1, so it's going to go 1, 2, 3 like that. Ethyl comes first alphabetically, so this is 2-ethyl, 1,1-dimethyl, cyclopropane. And next, we have an alkene. 1, 2, 3, 4, 5, 6. We can use cis-trans notation because we have methyl on carbon number 3 and also a methyl on carbon number 4. Let's just go ahead and use E because that's a little bit cleaner, a little bit fancier. So this is E. Our substituents are methyls on carbons 3 and 4. So 3, 4 dimethyl. Where's that double bond? It's on carbon number 3, hexene. Now we have a cyclic ketone. Ketone's high priority, so that's got to be carbon number 1. And then we want to give the chlorines the smallest possible number after that. So we're going to go counterclockwise. This is 2, 4 dichloro, cyclopentanone. And we don't have to say where the ketone is at on this molecule. Next up, we have this 5 carbon, is that 5? 1, 2, 3, 4, 6 carbon alkene. Our substituents are in a symmetrical position. So our goal is, if it's a tie, no matter how we go, our substituents are going to be on 3 and 4. So we want to do alphabetically the lowest number going to the substituent that would come first in the name. So our substituents are, before we get into substituents, we've got to do stereochemistry. Let me erase that because I think let's use E and Z here. So on this particular carbon, bromine is our high priority. On this carbon, the ethyl group is our high priority. So these substituents are not on the same side of the double bond. They're not on the same side, so this is an E. Let me put my numbers back. 1, 2, 3, 4, 5, 6. E, 3 bromo, 4 methyl, 3 hexene. And it would have been okay for us to say cis because we did have the ethyl groups on either carbon and the ethyl groups are cis to each other. So we have one left. Our priority here is to give the alkyne the smallest number. We want alkyne to be on carbon number 2. Our substituent is on carbon number 5. It's a methyl, 5 methyl, 2 hex, ine.